So this is an attempt to explain the generation of the tides. Okay, we only look at the Earth and Sun system. Okay, the Earth and Moon system creates something similar. So what you need to imagine, just imagine that you grab the Earth and you try to throw it past the Sun. And that's what happened very, very early on in the generation of the creation of Earth. However, there's a gravitational force. The gravitational force actually attracts the Earth towards the Sun. Okay, and with your attempt to throw the Earth past the Sun, the Earth actually becomes trapped. Okay, because the gravitational force is always directed towards the Sun and actually operates at a right angle with respect to the movement direction. And so as a consequence of that, the Earth actually moves around the Sun. Okay, and this is the trapping, gravitational trapping. The gravitational force is inversely proportional to the square of the distance, which means it's larger the closer you are to the Sun. In the Earth's center, so there's another force that is actually created, which is the centrifugal force. So on Earth, there's a balance in the center of the Earth. There's a balance between the gravitational force and the centrifugal force, such that the mean distance between Earth and Sun doesn't change. It's different at the surface of Earth, because there in some parts you're closer to the Sun, in other parts you're farther away from the Sun. So for a moment, just forget about that the Earth is rotating. Just look at a snapshot of the forces which are illustrated here on the right side. Okay, it shows you the centrifugal force is the same everywhere on Earth, but the gravitational force or the Sun's attractive force changes in direction, and it changes in magnitude. If you now work out the residual force, okay, you actually have in the location where you're closest to the Sun, okay, which is here. Let me show with the mouse. Which is over here on this side. Let me just try to get the mouse starting, which is here. The Sun's attractive force exceeds the centrifugal force. So you actually have a situation where the ocean, the water, is pulled towards the Sun. But on the opposite side of Earth, you also have that situation where the centrifugal force exceeds the gravitational force, so where the residual force actually tries to pull the water surface away from the surface. At the poles, you have a situation where you have a pull towards the Earth center. So the vertical forces only slightly modify the gravitational force, acceleration due to gravity. What creates the tides are the residual horizontal forces, which are these black arrows. So what these residual forces try to do is try to pull water towards the location which is located under the Sun, okay, and the opposite side of the Earth as well. So now if you let the Earth rotate around its axis, you actually expect to get two high waters during one full rotation of the Earth. This feature explains the existence of semidiurnal tides on Earth. Okay, you get two high waters.